Okay, so these are the video. This is the video for the application section of the show, which you know. It started off with Noah typically walks 28 feet. So again, this one asks you to do some drawing of your own. So Noah walks 28 feet north. So we're going to draw up, and we're going to label that 28. And then he walks 45 east. So that's the right. Okay, so 45. How much shorter would his walk be if he took a shortcut through the park or through the parking lot? So it's a multi-step question. That's why it's an application question. So the first thing that you really need to do is you need to figure out what the distance of his walking right now is. So if he walked 28 feet north and 45 feet east, so it's 28 plus 45, we know that his current walk is 73 feet, okay? What we need to figure out now is, okay, how much shorter would it be? So we know that this is the hypotenuse, so his shortcut is gonna be the hypotenuse. So a squared plus b squared equals c squared. We're gonna do a squared is 28 squared plus 45 squared equals c squared. 28 squared is 784. 45 squared is 2025 equals c squared. Add them up together. We're going to get 2809 equals c squared. We're going to use our square root. And we're going to find out that c equals 53. So this length is 53 feet. Now, some of you stopped right here, which is great. But you didn't give me the full answer, because the full answer asks, how much shorter would his walk be if he took the shortcut? So what we have to do now is we have to say, okay, if he takes his full route, it's 73 feet. If he takes the shortcut, it's 53 feet. He's going to walk 20 feet shorter if he takes the shortcut. That's the answer that we're looking for, okay? So just kind of an idea to make sure that you're reading the entire question and answering the question, not just doing the formula, okay? The next one that we looked at was the bird and the tree question. So it said a bird is on the ground 5 meters away from a tree, okay? If the bird flies, so he's 5 meters away from this tree. If the bird flies up 13 meters, how tall is the tree? So we don't know how tall the tree is. So that's what we're solving for. So a squared plus 5 squared equals 13 squared. A squared plus 25 equals 169. A squared equals 169. Whoops, sorry guys. Minus 25. So a squared equals 144. And then we plop this in. A equals the square root of 144. And so we know that the height of the tree is 12 meters. Okay? So again, that would be how to solve the tree one when we're given. It's pretty much the same as the knowledge question. It's just giving you a situation in the real world. The last one, and the one that I think a lot of people had challenge with, was the chart in the application question. So for instance, it said ABC, okay? And then it said the area of the square of leg 1. And then it said the area of the square of L2. And then it said the area of the square of the hypotenuse. So I want you to think about it in this way. We said that this area plus this area will equal this area. So a lot of people were doing this ABC question. You were given 9, 16. So this 9 represented 9 squared. This represented 16 squared. It was asking you how much was this. And a lot of you did the formula where you did 9 squared plus 16 squared. But all you had to actually do was add up these numbers. So the first one would be 25 squared, right? If you were given the second one, DEF, says that the hypotenuse is 64, and then it gives you 15, and it gives you plus something, right? You do the same process, right? You move 64 over to 15, right? So 64 minus 15, and you get 49. So when it's asking you for the area of the square, you're just adding up the numbers together, okay? So that's the application question. I'll be right back with the thinking questions.